Beneath the frozen plains of northern Asia lies a force older than civilization itself. It was born in ancient seas, buried under collapsing continents, compressed by time, and sealed beneath stone. Today, that force heats homes, powers industries, fuels wars, and shapes global politics. This is the story of Russia's geological wealth, how the earth created it, how humanity learned to extract it, and why even the richest land on earth cannot stand alone. This is not just a story of gas and oil. It is a story of rock, pressure, time, and consequence. To understand Russia's energy dominance, we must travel back hundreds of millions of years, long before ice, borders, or nations. Where Siberia now lies frozen was once warm, shallow sea. Microscopic marine organisms floated, lived, and died in vast numbers. Their remains sank to the seabed, buried by layers of sediment, sand, clay, and carbonate rock. Over time, pressure increased, temperatures rose, organic matter transformed. This slow geological cooking turned life into hydrocarbons, oil and natural gas, trapped inside porous rocks and sealed by impermeable layers. The earth locked away energy for the future. Long before humans learned to burn fuel, the planet was already preparing it. Russia's power lies not in one field, but in entire geological provinces. The West Siberian Basin, one of the largest sedimentary basins on Earth. Flat on the surface, explosive with energy below, holds some of the largest gas fields ever discovered. Fields like Urengoy, Yamburg, and Yamal supply energy to millions, formed by ancient seas and preserved by tectonic stability. The Volga-Ural Basin, older, oil-rich, closer to Europe. This basin powered the Soviet industrial rise and still fuels exports today. The Arctic Shelf, a new frontier, where hydrocarbons lie beneath ice, storms, and fragile ecosystems. Each basin is a geological time capsule, shaped by sedimentation, tectonics, and burial depth. Siberia is cold not just at the surface, but deep underground. Much of Russia's energy lies beneath continuous permafrost, where soil and rock remain frozen for hundreds of meters. Permafrost preserves gas fields, stabilizes geology, but complicates extraction. Drilling through frozen ground requires heated drill systems, special steel alloys, elevated infrastructure. Here, engineering fights geology every single day. The same frozen ground that protects Russia's gas also threatens the structures built to extract it. Natural gas does not flow from the earth ready for use. It must be extracted, purified, compressed, and transported. Extraction. Wells penetrate. Permafrost. Sedimentary rock. High-pressure reservoirs. At -40 degrees Celsius, metal becomes brittle. Human error becomes fatal. Processing. Raw gas contains water vapor, sulfur compounds, carbon dioxide. These must be removed before transport. Processing plants rise from frozen ground on stilts, so heat doesn't melt the earth beneath them. Russia's pipelines are among the longest engineered systems ever built. They cross rivers, marshlands, soft sediments, stable cratons. Major routes include Yamal, Europe, Brotherhood, Ukraine route. Nord Stream, Baltic Sea. Pipelines must survive. Ground movement. Thermal expansion. Corrosion. Geological stress. Geology dictates where steel can survive. For decades, Europe warmed itself with gas borne beneath Siberia. Before 2022, up to 40% of EU gas imports came from Russia. Some countries depended almost entirely on it. Why? Reliable flow, proximity, massive reserves, lower cost than LNG. European cities became unknowingly tied to ancient geology thousands of kilometers away. Russia's geological wealth extends far beyond hydrocarbons, oil, light and heavy crudes, petrochemicals, plastics, fuels, coal. Kuznetsk Basin. Pechora Basin formed from ancient forests buried and compressed. Metals and minerals. Nickel, Norilsk. Palladium and platinum. Uranium. Diamonds, Yakutia kimberlite pipes. These resources come from magmatic intrusions, metamorphic belts, ancient continental crust. Russia is not just an energy power, it is a geological superpower. Despite all this wealth, Russia imports critical resources. Why? Because raw geology is not enough. Technology imports. Russia depends on foreign nations for turbines, LNG refrigeration systems, drilling software, precision sensors. Without technology, geology remains locked underground. Energy transition materials. Russia imports lithium, certain rare earth elements, battery components. The fossil fuel giant depends on minerals essential for a post-fossil future. What once gave strength now brings risk. Melting permafrost. Climate change destabilizes. Pipelines. Roads. Storage facilities. Frozen ground shifts. Steel bends. Leaks occur. Arctic risk. New gas fields lie in. Storm-prone waters. Ice-covered seas. Fragile ecosystems. One spill here is irreversible. Europe diversifies. LNG from the US and Qatar. Renewables. Storage systems. Russia redirects. Eastward pipelines. Asian markets. But geology does not move quickly. Pipelines take decades. Markets change faster. For centuries, power has come from beneath the earth. Empires rise where resources concentrate. But geology does not guarantee permanence. As climates shift and technologies evolve, the same earth that once gave power can take it away. This story is not about Russia alone. It is about how the earth shapes civilization. Mountains define borders. Basins define wealth. Permafrost defines limits. Climate defines the future. We drill into the earth for power. But the earth always decides how long that power lasts. If you found this journey through geology, energy, and human ambition educational or thought-provoking, subscribe to the Geologic Lens, share this story, and leave a comment below. The Earth has many more stories to tell.